Okay, Shivanya, start.
A very fine good evening to all. Myself Shivanya, and I'm indeed pleasured to welcome you all to the last talk of the series of Insights in 20, hosted by IEEE Robotics and Automation Society chapters of IEEE SJCET, IEEE NSSCE, and IEEE LBSITW in association with RAS Chapter IEEE Kerala Section. I now welcome the speaker of the day, Mr. Shivoh Chirayil Nandakumar, Research Assistant at James Watt School of Engineering, University of Glasgow, UK, to this session. Last but not the least, I welcome the audience who are here today to learn new facts about robotics and automation in just 20 minutes. Without wasting much time, let's move on to the session. The session of the day is on the topic synergy of human robot interaction and telepresence. We may start now, sir. Over to you.
Okay. Hi. Good afternoon, everyone. So I am Shivoh, and I'm working as a research assistant, as Shivani said. So I'll start my session now, and I will share the screen at the moment. So basically, today's talk is based on the synergy of human-robot interaction and telepresence. So most of you might be wondering about what, like I think you might have a lot of questions regarding what is human-robot interaction and what might be the telepresence, or how do we combine these two. So basically, this will be the talk, or this will be the topic that I will be commenting on or discussing with you guys. So I will start with my basically I will start with my research as a research assistant at University of Glasgow, and then I will move on to the today's content. So basically, what I do in at university is like to figure out various kind of machine learning algorithms so that we can make the teleoperated systems, robotic systems, more efficient, in a sense that, like, if we want to move our hand, like, basically what we say is like, we are moving our hand in one place or in your college, and then you need to see a robot move the same way in somewhere else, in some other location, or in a country, or in another another continent or else. So to do that, there are a lot of aspects that we need to consider. Like, there is a lot, but I am not going more deeper into that. But basically, that's one of my research. And then I also do some kind of control algorithm. So like, you can see that there is a 2 or 3 robots in the picture. One of them, the small one, is called a Navo robot, which is like a bipedal robot, which, as you can see, it's a humanoid. So one of other research that I am currently working on is like developing the control algorithms for its movement, as well as the pepper which is behind that you can see. And another aspect of my research is based on like testing some kind of 5G network uh, for the robot that is in front of you, like the cube, like you can see a cube, a robot hand which is picking the cube. So I'm testing some kind of method to figure out the figure out the latency of the movement. So in the sense that, uh, I'm not going more deeper into that. It is like basically testing the 5G system that you might be aware of, which might be released in our day-to-day life in the future. So I'm not making you bored with my own research activities. So I will start with the today's session on the human robot interaction. So basically, these are the things that I will touch on, and then you can ask me if you have any further questions as well. So basically, I will introduce myself. introduce you to the human robot interaction and some of the various types of the human robot interaction based robots. And then I will move on to tell you some bits about the telepresence and what we meant by the telepresence. And then we will think of how we are trying to combine the human robot interaction or the idea of human robot interaction and along and combining it with the telepresence or the idea of telepresence. And then I will just give you a glimpse into some of the teaching methods that we are doing at the University of Glasgow, especially during this pandemic, how we coped with the remote learning method, especially how we are trying to control or program a robot while sitting at home. And then I will just explain you some bits regarding the current limitations of the human robot interaction and the telepresence so that you can imagine or you can use your creativity to explore more, and then maybe you might have or you might be the change to break the limitations as well. And also I will just give you a glimpse to the some of the future possibilities of human robot interaction. So let's start with the today's session. So anyone know about the human robot interaction? I am okay. This is not interactive. So I will basically start with the human robot. What is meant by human robot? I will start with explaining what is meant by human robot interaction. So basically, the human robot interaction is like, as you might intuitively understand, it is just a robot which is aware of its surroundings. So it is able to interact with the people in front of it, and it is able to communicate with the people. It is able to see the people and detect whether the person is smiling, or if the social clues or the social world that we live in, like the humans take it as a granted, in a sense that we know what we need to do in a social situation. We can easily adapt to the situations. But as a robot, it is just a machine, and it doesn't have its own understanding of the world. The understanding of the world is provided to it by ourselves, by providing various kind of algorithms and various kind of methods, or we need to think on how to provide them this kind of perceptive abilities to interact with the world. And that is the basic research, or that is the basic aspects of the human robot interaction. And so we will ask why we need this kind of human robot interaction. So as you might be aware, or as you might know, there are unlimited possibilities when we use the humanoids or the robots. So the basic idea is to have a collaboration with the robots to augment the human capability. So like there is we have our own intellectual, or we have our own capabilities as a human, and we do know that some aspects of the robots are very efficient, in a sense that it will be able to augment our own capabilities. So it is more like helping ourselves to be a better human. So that's the basic idea of that's a basic necessary basic need, that we need a human robot interaction, or that robotics generally. So that's why we need this kind of human robot interaction and the robotics in the society. And then there might be some kind of confusion between you guys, or between the everyone. So in the beginning, like, what is a difference between robotics and human robot interaction? So I would like to explain in a simple manner, in a sense that this is most basic method, but there are human robot interaction is actually subset. It's actually a combination of many layers or many subgroups or groups, but these are the main contributors that provide to the human robot interaction. So robotics is just a small part of that contribute to the human robot interaction. So basically, I can give you an example in a sense that a robot is a machine which can actually provide, or which can actually sense the world outside, and according to the state of the environment that is the outside environment, they will take a decision, and then it is provided that decision is actually provided to the environment, in a sense that, let's say, there is a uh, industrial arm is just an robotic arm. It will We can actually program it to pick a box and then place to another box, right? So to another place, sorry. So basically what happens is, like, they are not aware of what's happening around them. They are just asked to pick a box and then to place it on some place else. So they are not aware whether there is a human, whether there is uh, someone happy sitting there, or someone sad sitting there, or like what's happening. Even if the building is falling down, they are not aware of anything that is happening around them. So that is, but it is also a robot. So human robot interaction and robotics are having, like, there is a difference, and I thought of explaining with this kind of example. So human robot interaction, we can actually, the robots should be having a capability to understand the social world around it, even though they may not be able to perceive as richly as we humans have at the moment. They are still learning to understand the world in a better way. So to do that, we actually have this another subset called human computer interaction that we all already have in our hands, or like we can say that the mobile phones or anything or similar is called, it can be provided, I mean, as an example of human computer interaction. And then uh, the important part is the artificial intelligence. It is just training the model to be a better, to get adapted to the situations. So, like, it will learn from the situations, and then it adapts to be a better efficient system in the long run, like collecting the data and become better as it evolves. It do have its own limitations, but I am not going deeper into that. So this is a basic idea of human robot interaction. So basically we need the robots to understand the surrounding. That's the basic task of human robot interaction. So I will move on to explain, share you about a few types of human robot interaction based robots. I will explain a few types of robots. So, like, basically the humanoids and the cobots are one of the major human robot interaction based robots. Humanoids are basically the robots which have similar features and which have a kind of similar aesthetics of a human, and they are used mainly in the service sector of service industries. So you might see in the hospitals, in the care rooms or care areas, or in the hotels, or anywhere similar, like where there are a service type of, they are basically acting as a service type of robots which can actually provide you interact with the human in a almost very convenient way, even though there are limitations with the natural language processing and other aspects. It is still evolving as a good prospective, uh, it have a good market in the service sector. And the cobots are basically the collaborative robots. It is basically the industrial arms, or the it is basically used in the industries where So far, the industrial arms, as I mentioned earlier, doesn't have the awareness of what is happening around them. So now we are moving on to the collaborative robots, in which the robots will be having awareness of what is happening around them. So like if there is a person who is working with the robot, it will be aware of the person, and if the person is very nearby, it will stop on its own. And if it touches, or a human accidentally touches the robot will stop at the moment. So there is they are very safe to be worked with. So these are the basic two. And then there might be a lot of other robots which are based on HRI, and it is only limited to your imagination actually. So I will just introduce some of the uh, robots that we see as a humanoid. So this is a Pepper robot, which is basically a 4 feet tall humanoid without having. It's actually a semi-humanoid in the sense that it doesn't have the legs. So basically, it do have all other aspects of a human, but it doesn't have the legs, so it will float in the place. So it's a 4 feet tall with a very good sensor system and actuator systems. And then we have the Navo robot, which is basically a very small robot in the sense that it is just 56 centimeter tall, and it is also, but it is extremely complex system in a sense that the bipedals, if you are into the robotics, you might be able to know that the bipedals are one of the complex systems that we can imagine. The control algorithms or the control structure inside the bipedals are wonderful, and managing them or moving them to manipulating or maneuvering them is a wonderful phenomenon if you are looking in the perspective of a control engineer or the control system engineer. So this is one of the humanoids which can interact with the humans and have a basic understanding of the world. Not as precise as the humans, but have a kind of understanding. So this is, I'm sure you might be aware of uh, the Sophia and Sophia, and maybe a bit less aware of the Little Sophia. So Little Sophia is just another small robot which can be used by the STEM educators to make students learn about AI, the robotics, and the human-robot interaction. I'm not going more detail into Sophia, as you might be completely aware of and how they are interacting with the world, as you might have seen a lot of videos as well. So I will just move on to the world of cobots. As I had previously mentioned, the cobots are the collaborative robots which are used in the industries now, and these are some of the examples. One of the good collaborative robots that we have at the moment. This is the Baxter robot, which is actually two robotic arms with a 7 degree of freedom each, and it does have a good tablet on as a face. It can show some kind of emotions to make it more friendly. And this is one of the collaborative robots. It can actually detect or perceive the humans or aware of the environment in a limited way. And this is another one of the very good collaborative robotic arm, which is extensively used in the industries for many of the manipulation or um, other purposes. And it is yeah, it do have the 7 degrees of freedom, and then you can see that we can attach any kind of act end effectors to make it more effective. And so far now we have explained what is human robot interaction. So basically human robot interaction is, as previously mentioned, it is providing them a awareness of the society that we live in. or basic awareness to the things that is around them. And the other aspect that I would like to discuss today is the telepresence. And so basically, I am interested in showing you a video rather than explaining the telepresence. So I will share the video at the moment right now, and you will be able to understand it more precisely.
By 10, 5 by 2.
So I hope you might be able to. I hope you have got a glimpse of what is meant by telepresence. I will just explain what is meant by telepresence in a sense that we should be able to experience the things that is happening around outside the present realm of our life. So just as you can see, like in the future, like we might be able to experience how the sand in the moon will be by just sitting at our home. So that is the basic idea of telepresence. So as you now have the understanding of the human robot interaction and the telepresence, I will move on to explain how do we combine the human robot interaction and telepresence. Or it is just a narrow line in a sense that it doesn't have a specific kind of splits between the human robot interaction and telepresence, but I will make you aware of, make you give you a bit more a bit more understanding of how we are combining this. So for that, I will show you another video which will be used in the future for making these dreams a bit more real. So at the moment, the Pepper robot that I had shown you before is now able to combine the technology of teleoperation with telepresence. So it means that uh, the teleoperation, as I mentioned, is like controlling the robot from while sitting here and controlling it in America or in somewhere else around the world. And the telepresence, as you have seen, is to experience the place around it. So I will show you a video regarding this, and it will make you much more, it will give you much more clarity on the how we are trying to combine both sides of the world.
Hallo Opa.
Hallo Charlie, schön, dass du da bist.
Hi Karen, how are you?
I'm okay. I'm still quarantined at home for 1 more week.
Well, I hope to see you back in the office very soon.
Bye.
Bye-bye.
We talk of telepresence when the focus is more on helping communication between two people, which is a bit of the simpler case. But often we also want teleoperation, in which case not only are you talking to people through Pepper, but you can also be driving Pepper around. So when people talk about telepresence or teleoperation, there are actually a lot of quite different use cases. For example, Pepper in a reception area that can talk to people and put you in contact with employees. Pepper in a hospital that allows to visit sick family members. We have built something more like a telepresence toolkit with a lot of components that you can combine together to build something corresponding to your use case. Pepper will automatically detect obstacles and not get too close to them, and will never hit into them. Another important aspect is security. You have on one side a web page through which an operator can control Pepper, and on the other side, maybe a different city, you have Pepper, and we need to ensure that.
So I hope you will have got basic understanding of that, in a sense that what they are trying to do is to have a kind of telepresence, in a sense that two humans from one place, from one location to other location is interacting. Basically, it is already happening in a sense that we are having the Skype and everything, but in a sense that we are actually trying to, this is the beginning in a sense that the synergy that I mentioned earlier is extremely futuristic, in a sense that at the moment that what you have seen is just how the humans can have this kind of visual feedback as well as the audio feedback, and in the future we can create systems which will be able to interact with the other side of the world, or basically we can actually control the Pepper's arm as if you are the Pepper, or we can create robots which can actually act as a exoskeleton for you. So it do have a great future, and it do have a great possibility, and this is just the beginning, and that's what I was trying to explain through that videos. And lastly, I will just mention about how the research or how the teaching at our University of Glasgow is happening, in a sense that especially in the COVID situation. So basically there was a course for the real-time computing, and for that we do the remote learning process, remote learning method. And as you might aware or might not, the University of Glasgow, and then there is a university in China, and they have an international collaboration program in which the University of Glasgow is teaching the undergraduate courses in China, in that Chinese university. So basically for this course, the students in China as well as the students in Glasgow, they both, as you can see in the current slide, the students who are sitting at home will be able to remotely access the lab PC which is in our university, and then it will be able to connect with the pepper robot in our lab, and then he can interact or program the pepper robot from sitting at home. So the students were able to learn how to program the robot while sitting at home. And the interesting aspect is that it is not happening not only in Glasgow. The students in China as well was trying to, or were trying to do the similar remote access on the pepper in Glasgow. So it is like a continent, like different continent, they were trying to access remotely. And the project was successful, and many students presented their projects. And this is one of the project that the students have done. I will share the video via another link.
Not audible.
There is no audio. Sorry. I will,
Well, it's already 3 p.m., so good afternoon.
Haha, nice to meet you. I heard that you are the assistant of Team 6.
Yeah, you are all my friends.
Well, they told me that you can imitate animals very well.
Definitely. You can name any animal that you want me to perform.
Fine, what about a gorilla?
Sounds great.
Can you understand Chinese?
How? I am still learning Chinese, but I can understand Chinese. You can speak Chinese to me.
你好，
Hi.
星星给我弹个吉他。
Okay.
你弹的真好听。
Hi. Thank you.
你能帮我拍照吗？
Sure. Cheese.
Wow, you are so clever.
Sorry, I do not understand what you are saying.
哦，我忘了用中文和你交流。那现在请你结束表演，并用英文和我对话吧。
Okay, I am Pepper now. You can talk with me in English.
Can you take another picture for me?
Sure. Cheese.
Amazing.
Thank you.
So, I think the time is already running out. Sorry for that. So now I'll move on to the current limitations that is happening. That is in our human robot interaction, as you might be aware or not. So basically, the issues when we are trying to combine the human robot interaction with the telepresence, it is the latency. Latency is like how fastly we can transmit the data so that we can see the movements in from one place to another without much time delay. So that is one of the issues we are trying to solve, or people are trying to solve. And then we have this control algorithm accuracy that is needed, that is extremely needed for the safety of humans, as well as the for all other purposes as well. The control algorithms, we need to have much more efficient control algorithms in the future. And when we are talking into the human robot interaction in a sense of talking and speaking, and talking and that kind of voice interactions, we need to have this kind of natural language processing algorithms and voice recognition algorithms, which should be much more robust. And then obviously we do have the kind of hardware limitations, which will basically the size, and then there is the processing power, which we can build on, which we can use on the robot because of the size. Like, we need to have the high computational power, but we shouldn't be using we cannot use a big machine on to the or placed in the robot. So these kind of hardware challenges as well as software challenges are in front. But yes, I do see there is a billion possibilities. I do see there are billion possibilities to figure it out and solve. And yes, if you have any questions, I think the time is already very late. Yeah.
Thank you, sir, for that amazing session. We already have a question in the live chat. Shall I read it out?
Yes.
Yeah, the question is, is Pepper Robo based on IoT?
So IoT is like a branch, or it's a Internet of Things, right? So yes, we can use the IoT in the Pepper, or in a sense that it is not an in a like exhaustive list. We cannot say that Pepper is an IoT, but we can use Pepper in as an IoT, if that sounds fine.
Yeah, sir. So, guys, if you have any queries related to the topic, kindly put it in the YouTube live chat. We may read it out. Guys, if you have any queries related to the topic, kindly put it in the live chat. We shall read it out.
And they can also I can share the email ID if they would like to ask in the future as well.
Sure, sir, sure.
If you would like to. Yeah, so I will type my email ID in the live session.
So, guys, you can clear your queries by contacting him via his email ID. So yeah, moving on, I now invite Jisha Via, Chair of Robotics and Automation Society Chapter, IEEE Kerala Section, to deliver the vote of thanks. Over to you, ma'am.
Yeah. Well, good evening, everyone. And thank you, Mr. Shivoh, for for the enlightening session on human-robot interaction. Hope the participants have got an idea about the same, as well as telepresence, right, also. So you could see that he has been working with wide variety of robots, mainly humanoids. So if you also wish to work in this area, do try to have an exposure in all these areas before pursuing your higher studies in robotics. So you can also be able to do the same. So on behalf of Robotics and Automation Society Chapter of IEEE Kerala Section and RAS Chapters of SJCET Palai, NSS College of Engineering, LBSITW, and everyone attending this event, I thank Mr. Shivoh for accepting our invitation and handling the concluding session of Insights in 2020. Sorry, Insight in 2020. So thanks to all participants who attended this session. See, Robotics and Automation Society Chapter, IEEE Kerala Section is so happy to associate with this innovative program, Insights in 20, which seems to be a successful one with very good participation of students. So great effort from RAS teams of SJCET, Palai, NSS College of Engineering, and LBS IT for Women. Kudos to all the team members who worked hard to make this a grand success. And the success of any event is the enthusiasm shown by the participants, right? So we express our gratitude to the participants who have shown interest in this event. Thank you for all your support and hope that you all have benefited out of this. And thank you all once again, and bye-bye from the RAS team of Kerala Section. Thank you.
Thank you, ma'am. With that, we have come to the end of Insights in 20. Participants, kindly fill in the feedback form, which will be counted as your attendance also. The link for the feedback form is given in the live chat. Thank you. Have a nice day.